Hello, in this Vulkan video we are going to be looking at uniform buffers. We'll start off with the descriptor layout and buffer. So what we'll also be doing is looking at transformations as well. We'll be looking at the rotate transformation. So we'll be setting up the descriptor layout and buffer in this video. The next video will wrap things up and actually get the rotation working. So this is going to be a two-part uniform buffer video. So pretty simple. Let's go ahead and start that. We'll be doing like model view projection in here as well. So if you come from OpenGL and you know about that sort of stuff, then you'll feel right at home here. So at the top here, we're going to put hash define glm underscore force underscore radians, like so. And we're forcing GLM to use radians, and this prevents any confusion when actually using methods like rotate and translate. And we also need the header for the matrix transformations. So hash include glm /gtc /matrix transform.hpp. Okay, so now that we've got those in there, what we also need is don't know why that's still moaning. There we go. We'll also need another include hash include. I'll minimize this a bit just so it's easier while we're coding it out. Chrono, and the Chrono standard library header, it basically exposes functions to precise timekeeping, and what we're going to do is use this to make sure that our rotations, when we actually do that at 90 degrees per second, are actually rotating that amount regardless of frame rate. So what we don't want to happen is the frame rate doubles and then it rotates 180 degrees instead of 90, or if the frame rate halves from the baseline and then it's rotating 45 degrees a second. We don't want that. Yes, the higher the frame rate, the smoother it will look, but the amount of movement or rotation or transformation that has occurred should be the same. That's basically what this will be doing. And yet red line has disappeared as well, which is fantastic. Next, we're going to scroll down to the vertices vector, and we're going to create a struct called uniform buffer object. And this is going to have the model, view, and projection matrices. So glm : mat for model, semicolon, glm : mat for view, glm : mat for projection. So we just put proj for that, and we've defined the uniform buffer object here in a struct format. So next, what we're going to do is create some variables, and we'll go to where we've got the render path, and over here we're going to create a vk descriptor set layout underscore descriptor set layout semicolon. Okay, and what we'll do now is where the command buffers are, we're going to create the uniform buffer objects and the uniform buffer memory objects as well in a vector. So vector vk buffer underscore uniform buffers std : vector and vk device memory underscore uniform buffers, and we'll call it uniform buffers memory, like so. Okay, so the next part is we're going to go to the init Vulkan, and after we call the create render path, we're going to need to make sure we provide details about every descriptor binding used in the shaders for the pipeline creation. And just like we have done for every vertex attribute and its location index, we'll set up a new function that will define all of this information, and we'll call it create descriptor set layout. So create descriptor set layout, like so, semicolon, and we're going to call a method after the create index buffers method to create the uniform buffer. So create uniform buffer, semicolon, and now what we're going to do is scroll down to clean, swap up chain, and right at the bottom we're going to clean up the uniform and the uniform buffers memory objects. So we're going to say for unsigned long I equals 0, I less than underscore swap chain images dot size I plus plus vk destroy buffer and underscore device underscore uniform buffers and no pointer. Okay, so we're going to put vk free memory to free the uniform buffer memory objects, and we need to pass in the Vulkan device, the uniform buffer memory vector, and the particular one that we are going to be doing, and for the callback we'll put no, semicolon. Okay, so next what we are going to do is in the cleanup, we're just going to clean up the descriptor set layout object. So I'm going to put vk destroy descriptor set layout. We're going to pass in the Vulkan device underscore descriptor set layout and no pointer for the callback again. Put a semicolon. And now we're going to go down to where we've got the recreate swap chain methods. Should have been here somewhere. Let's try and find where I actually put it. Recreate. Oh, there we are. The recreate swap chain, and what we are going to do is after the create frame buffers, we're going to put create uniform, which we have not implemented. That create uniform buffers, like so. Okay, so next what we'll do is we'll scroll down to the create render pass method. So create render pass method, and after that, but before the create graphics pipeline, we're going to create the descriptor set layout. So we're going to say void create descriptor set layout, and first of all, every binding needs to be described through a vk descriptor set layout binding struct, which is what we'll create now. So we're going to put vk descriptor set layout binding UBO layout binding semicolon, and the first three fields basically specify the binding used in the shade and the type of descriptor, which is, you know, a uniform buffer object. So we're going to put UBO layout binding dot binding, put that to 0. We're going to put UBO layout binding dot descriptor count, and there's only going to be one of these. We're going to put UBO layout binding dot descriptor type, and it's going to be equal to vk underscore descriptor underscore type underscore uniform buffer semicolon. And what we'll do now is we'll set the p immutable samplers parameter, property, and this field is really only relevant for image sampling related descriptors, which we are going to look at later, but for now we'll leave it at its default value. And to do that, ub layer binding dot p immutable samples equals null pointer semicolon, and put ubo layout binding dot stage flags equals vk underscore shader underscore stage underscore vertex bit, like so. And this just specifies which of the shader stages the descriptor is going to be referenced, and for us it's the vertex stage. Okay, so now what we're going to do is create the layout info for the create descriptor set layout method. So we just put vk descriptor set layout create info layout info, and we specify the type of struct it is expecting. So we put layout info dot s type equals vk underscore structure underscore type underscore descriptor underscore set underscore layout underscore create underscore info, and let's put a semicolon, put layout dot binding count equals 1, and put layout dot p bindings equals a reference to UBO layout binding semicolon. Yep, we need layout info, that's why we're getting an error. And okay, so now that we've bound it, what we're going to do is try and actually create the descriptor set layout. So I'm going to say if vk create descriptor set layout, so underscore device, a reference to the layout info, and for the callbacks we're going to put null pointer, and for the descriptor layout we're just going to pass in a reference to underscore descriptor set layout, and if this is not equal to vk underscore success, we're going to throw a runtime error, and we're going to simply say failed to create descriptor set layout, like so. Okay, so now that we've got that, the next part that we're going to do is go to the create graphics pipeline method, and we'll go to, because there's a lot of code here, so we're going to make sure we're putting it in the right place. Go to where we've got pipeline color blend state create info, blend state create info, and after that we have the pipeline layout create info. And what we want to do is change a couple of things up. The layout count is, because we do have a layout now, we're going to put 1, and instead of this we're not going to push a constant range count. What we're going to say is p set layouts is equal to the reference of descriptor set layout, like so. And next we are gonna go and create the create uniform buffers method, and we can do that just below the create index buffer method right here. So we'll say void create uniform buffers method, and first of all we're just going to match the size of the swap chain images to the uniform buffers. So we're going to say vk device size, and I'm going to put this a buffer size equals size of uniform buffer object that we created above that struct. So we get the size of that. We're going to say underscore uniform buffers dot resize, and resize it to the swap chain images dot size. And we're doing something very similar again, but we're resizing the uniform buffers memory vector now, still to the swap chain images size. And now we're going to create a buffer for every image in the swap chain. So we'll say for unsigned long I equals 0, I less than underscore swap chain images dot size I plus plus, and we'll say create buffer, got buffer size vk underscore buffer underscore usage underscore uniform underscore buffer bit, and then we're gonna pass in the property flags, and for that we're gonna or the vk underscore memory underscore property underscore host underscore visible bit with the vk underscore memory underscore property underscore host underscore coherent underscore bit. And next we're going to specify the buffer itself. So we're going to say underscore uniform buffers, and we're going to put I, and then finally we specify the uniform buffer memory. So we're going to say underscore uniform buffers memory, and we're going to put I like so. Okay, so now that we've got that done, what we are going to work on next is creating the update uniform buffers method. So we'll do that just before we call draw frame. So if we go down to draw frame, should be put okay. So we'll just do it right here. And so we're going to update the uniform buffers, and the update uniform buffer function that we're going to create will start out with some logic to basically calculate the time in seconds, since rendering has actually started with floating point accuracy. So we're going to put void update uniform buffer unsigned int current image, and make it static auto start time equals std chrono high underscore resolution underscore clock now, and we'll put semicolon auto current time equals std chrono high resolution clock and now. So we got start time and we got the current time, and this one will be a static so it persists. And what we're going to do now is get a float time equals std chrono duration, and it's going to be a float std chrono seconds period, and current time minus start time dot count like so. Put a semicolon. So now we will define the model view and projection matrices, and also any transformations in the uniform buffer object. The model rotation will be a very simple rotation. It's going to be about the z-axis, and you're factoring the time variable so that way it's frame rate independent. So we'll create a uniform or an instance of the uniform buffer object struct, call it UBO for uniform buffer object. Pretty simple stuff. Put a semicolon and put UBO dot model. So the model matrix is going to be equal to glm rotate glm mat for 1.0 f, And now for the angle, we're going to put time times by GLM : radians, and we'll just put 90.0f, so that's 90 degrees, but you'll convert it to radians. GLM : vec 3, and now we specify the axis to rotate about. So 0.0f, that means don't rotate about the x-axis. 0.0f, don't rotate about the y-axis. 1.0f means rotate about the z-axis. Okay, so now for the view transformation, what we're going to do is look at the geometry from above, and it's going to be from a 45-degree angle. We'll use the GLM : look at function, which, it takes the eye position and the center position and up axis as parameters. Pretty simple to do this. It sounds more complex than it actually is. Put UBO.view equals GLM : look at GLM : vec 3 2.0f 0f 2.0f and 2.0f. And now we're going to specify the center as GLM : vec 3 1.0f, 0.0f, 0.0f, and we're going to put GLM : vec 3 0.0f, 0.0f, 1.0f, semicolon. And now what we're going to be doing is we'll use the perspective projection with a 45-degree vertical field of view, and the other parameters in the projection matrix that we create for the perspective from GLM are aspect ratio, near and far, view planes, also known as clipping planes as well. Just note, it is important to use the current swap chain extent to calculate the aspect ratio and to take into account what the new width and height of the window after resize is. So we have to factor that in. Again, we'll do that, and it's not too difficult. We'll put UBO.proj equals GLM : perspective, GLM : radians, 45.0f underscore swap chain extent dot width divided by, we'll cast this to a float, underscore swap chain extent dot height. By casting this to a float, the overall calculation will now be a float as well, so we'll get higher precision. 0.01, 0.1f, sorry, and we'll put 10.0f as well. And it's pretty common to have something like 0.1f for the near clipping plane. Okay, so now that we've done that, what we'll do now is we need to do something, because GLM was actually originally created for OpenGL, and that's fine for the most part, but the y coordinate of the clip coordinates is actually inverted. And the easiest way to actually overcome this is just to flip the sign on the scaling factor of the y-axis in the the projection matrix. If you don't do this, your image will be rendered upside down. So if that happens, just make sure you've got this line. So UBO.proj multiply equals -1. Make sure you got this. If it's upside down, it's probably something to do with this. So all of these, transformations are defined now, which is good. So what we can do now is copy the data in the uniform buffer object to the current uniform buffer. This happens, in pretty much the same way as we did for the vertex buffers, but without a staging buffer. So we'll have a void pointer, and we'll put vk map memory, and we'll specify the device underscore uniform buffers memory current image, and for the offset we're going to put 0, and then we're going to do size of UBO, and we'll put flag 0, and then we'll put a reference to our void pointer. Close it off properly, and we'll do a mem copy, and we'll pass in the the void pointer, reference to UBO, and we need to specify the size of the UBO, and we do this by doing this. And finally in here I'm going to put vk unmap memory, and put device underscore uniform buffers memory current image semicolon. Okay, so we are almost done now. It feels like, you know, we've done so much code, and like it's almost like, when's it gonna finish? Right now. So all we gotta do is go down to the draw frame method, and after, actually before the image is in flight check, but after we check the result, what we're gonna do is say update uniform buffer. So we need to update it here, pass in the image index. We can give it a run. All goes well, it should run, but it won't actually, you know, do anything yet. So all goes well. We should have, oh, we're getting some errors. That's fine. We'll fix whatever error we got. Create uniform buffer. Yeah, that's strange. So create uniform buffer is. I think it was actually called create uniform buffers. Yes. Give that a run again. And okay, so what we'll get is a low error, and that's fine because we still need to, you know, fix all this in the next video. But before we do wrap up, we've got one extra thing to sort out. We need to modify the vertex shader file, so we're going to go ahead and do that now. I'll go to the project and res shaders, and we're going to be modifying the shader.vert. And so if I open up, let's say Sublime, I drag that on. So let's update this. So actually this is the old version. I mean, this is the current version, sorry. So what I want to do is actually show you what needs to be updated. So I'll whack the old version in here so you actually have, so you can see what I'm doing. Obviously you won't be doing this because you'll be doing the new version with me right now. Okay, so what we're going to be doing is creating a uniform buffer object. So we're going to say layout binding equals 0. I'm going to say uniform, and it's going to be a uniform buffer object, and similar structure. It's going to be a 4x4 matrix, and that's for the model. And we're going to have a view matrix as well. So map for view, we're going to have a projection matrix as well, which is a 4x4 matrix, semicolon, and we put UBO for the uniform buffer object. We're still doing all of this, so that's not changing. We're still doing the frag color, which is getting passed to the fragment shader. We're not changing the fragment shader. We'll get rid of this and we'll update this. So we're going to put UBO dot proj asterisk UBO dot view asterisk UBO dot model, and it's important that you do it in this order, otherwise you know potentially might get something different and unforeseen, problems. And just times that by the vector of in position and 0.0 and 1.0 semicolon. And before we wrap up, we just need to compile this, and we'll get rid of the vert.spv because that's the one that we're going to be converting this to. Do that. Okay, so it's not appearing. That gives me a good indication that something has gone wrong. So what we'll do is, I've probably made some mistakes somewhere, so I'll cd to this folder, and let me reduce the size of this slightly. Okay, and when you change drives, you'll do something like this, and I'm going to put gl slc.exe and we'll put shader.vert. Okay, so we're getting some errors. Let's have a look at what we're getting. It seems like a lot, but it'll probably be just because I've named something incorrect. Proj now, so if I rerun that, there we go, it's been created just because of that one error. That happens, and I'm going to rename that to vert.spv, and that's it. So if we give this another run, nothing should, still should change because we haven't done the next video, but in there we'll wrap this up and we'll actually have our object rotating around. So that's it for the descriptor set and layout, and the descriptor layout and buffer. If you have any questions, feel free to join the Discord group. There's a link in the description. Just pop over into the Vulkan channel, join it, and just post any questions you have. More videos come in. If you want to check out the source code along with working projects, you can check that out in the description as well via the GitHub page. That's it. Thanks for watching, and I look forward to seeing you in the next video.